first of all, why do they explain to me like why do they take school day off to take kids out to like golf competitions? That just doesn't make sense. I mean, I'm just like I'm not only last me, also Lena, also a lot of students. I don't know why. Like football, you do it after school. Soccer, you do it after school. But like a golf, it's take kids out of school. Then you do it a weekend. I know that's what pissed me off. Like, no, the reason why I'm asking is because I have a student that's doing golf and she's behind, and and then you just take another day off and then you're just gonna behind more times. I'm like, that's not making any sense. Lakshmi's not behind, so she's fine. Okay, so so what we're gonna do is we're gonna say, um, how do we find, how do we approximate something, using tangent line approximation? Let's just say if I have f of x is equal to 1 plus sine of x, and at point 0 comma 1, we know is 0 is gonna comma 1 here. And I'm gonna show you the comparison between two, okay? So the idea is, now this idea, again, this idea is gonna go to, it's already, we already did it in Calc 1, but its idea is gonna use the same idea, go into the BC calculus, which is something called Taylor series and Euler's method. So even something like this is very easy, but you guys still knowing what you're doing. So I can take a derivative of this, which is derivative is this is going to be what? Cosine of x, right? So I can plug in 0. What's the cosine of 0? Then that's going to be cosine of 0, that's equal to 1. So that's going to be y minus 1 equal to 1 times x minus 0. So it'll be y equal to x plus 1. Now, what is y equal to x plus 1 and this have in common? It just means that if x is changing that very, very small value, so I'm going to show you on Desmos. So if I have a small value in there, let's just say I want to approximate at 0.1. You know, what would be the comparison between those two things? So if I were to plug in 0.1 on this function, and if I plug in 0.1 on this function, ideally, it's not too far apart. And I'm going to show you why that is. So ideally, this one is going to be 1 plus sine of x. And this one is going to be y equal to x plus 1. Sorry, 1. Now, if you look at here, right? Basically, from 0.1, which is you look down here, 0.1 on the bottom, to positive 0.1, negative 0.1, positive 0.1, the evaluation is almost very, very, very similar. Almost very, very similar. It's like let's show you. This one's, we're gonna show you this one's f of x. F of x here. Equal to this. And then I'm gonna say this is g of x, and then say g of x here. And then we can say f of 1.1 versus g of 1.1 is, wait, hold on a second. Did I do something wrong?
It's 0, 0, 1.
Oh, 0.1. Thank you. I'm an idiot. 0.1. So 1.1 doesn't work, obviously, because that's too far away from the tangent line. But something that's really close, that you can see that one is 1.099 and 1.1. Which one is the correct value?
1.0998.
What?
The top
The top one's the correct value, right? The g of 0.1 is actually approximation. Now it turns out that later we can use Taylor series and we can somehow make a bunch of polynomials to imitate the graph of sine of x. But this is a very beginning stage of it. This is a very beginning stage of it. Is because at this small area, it's exactly, I'm not saying exactly identical, but it's very close to actual approximation. Your approximation is very, very close. Now, is 100% right? No, it's gonna be like small margin error, and that error is so small, it's almost negligible. Long as your delta x is not really big. So imagine if I were to plug in 1.1, what I just did, I made a mistake. At 1.1, it's gonna be a big difference. But if at 0.01, it's gonna be small difference. 0.1 is gonna be small difference. That's just to show you, let's say 0.01 here and see how close those value there. So 0.1, and that's almost 0.001 difference. The approximation is very, very, very small. That's why we're using something called tangent line approximation. How many times last year you saw it on FRQ? Almost every single question is like, use a tangent line approximation to approximate this. Or just basically using tangent line and plug in a value. That's it. So how did, a long time ago, how did those people calculate, how did the people calculate square root of 25 point, I say it's 24.9? How do they approximate this value? How do they approximate square root of 25? Or 24.9, sorry. And this is on your competition test. A lot of time they have competition test question like this. Because they say you cannot, because competition you're not able to use calculator. But you says, hey, how do I approximate square root 24.9? So this is some question I didn't give you last year, but it's on the competitions. Yes.
Would it be like very close to like square root 25?
Uh-huh. Yeah, it's but I want to approximate this. I want to use equation tangent line to approximate this. How do I approximate this? Right? Yeah, you can. It's gonna be very close to 5. But if I were to use tangent line approximation, how would I approximate? Start out at Nathan. What's your idea?
You can do a tangent line approximation, so you use root x.
So you're gonna say it's y equal to x to the 1/2, right? Why is root x? Because this we try to approximate this y equal to square root x, so we can convert to this. Is that okay? And let's take derivative. So dy dx is equal to what? 1/2 x to the negative 1/2, right? Are we okay here? Okay. So then I can have, there's two ways to do it, is to consider how much of the changing of y. So you can do it two ways. So let's not do an equation tangent line. Let's just do differential. So 1/2 root x dx. And we're gonna use equation tangent to approximate in a second too. So the dy is how much it's changing of y, right? And this is how much it's changing of x. Is that okay? So it will be 1 over 2 root what? 25, good. And what is the dx? Be careful, what's dx?
1
No,
minus 25
which is what?
21 or negative 21.
Negative 0.1.
Oh, yeah.
Later we're going to use the equation tangent line to do it, but right here is another way to do it. So that's going to be 2 times 5 times negative 0.1. So that's equal to 1 over 10 times what? Negative 1 over 10. So it'd be negative 1 over 100. So this is a delta y, right? This is how much your y changes. So that means if you got 5 minus 1 over 100, that's going to be your approximation. It's going to be 499 over 100. And let's try it. 499 over 100, so 499 over 100. It's a 4.99, but square root 24.9. It's a 4.9899. If you round it to like one decimal, like I think 0.001, you would get a thing. Now this way is I figure out what the dy is, right? How much you change in y in term of 5. Is that okay? Yes.
I get the dx.
Dx is how much you known value. So start with compare with you know square root 25. Yeah. So from 25 to go to 24.9. Right. So can you use the equation tangent line to get the same thing? Exactly the same thing, because it's gonna be what? Y minus what is the output here? Y minus y1 equal to m times x minus x1. Think about the same thing. So y minus what? This is gonna be 5, right? Equal to m times x minus what? 25, right? And m is what? 1 over 2 root 5, right? So it'd be negative 1 over 10 times x minus 25, y minus 5. So what we're trying to approximate? We're trying to approximate this part is 24.1 or 24.9, sorry. So would that get you negative 1 over 10 times dy, which is here it's going to be dy, so it'll be negative 0.1. Y minus 5, so y equal to 5 plus.
That's not right. Negative 0.05.
It should be.
This
1
one should
over
be
10,
positive.
Not negative 1 over 10. because
Yeah, this
it's
one
not
should, so that's gonna be 5.
Yeah, because what I did, I
minus-
didn't do the dx thing that you did.
Yeah, and it doesn't matter which way, but this is how you use equation tangent line, which is that's what AP exam wants you to do,
Either way.
like this. Yeah, no, this way is more what AP exam want.
Which way?
The right way, the equation tangent line. But this is just what happened because you study how much it's changing a y compared to the original value.
Dx is the change between the active.
Right. Is this okay?
The dy, but how is it? Why is the dy negative? Because it's always increasing.
No, dy is a negative because you know 25, but you don't know 24.9. So from 25
Oh,
to
I see.
24.9
Yeah, in
is
relation
actually
to that, I
subtracting.
see.
Yes. Because this part. So this one is the square root 25, right? But in order to approximate square root 24.9, it's gonna be 25, square root of 25 minus how much you change your y. Or plus how much you change your y. In this case, y is -1 over 100, so you subtract by 1. Or you can use the equation tangent line. You see this part is going to give you the dx, right? That's how much your x is changing. That's going to give you the same x change.
Yeah.
So it regardless the same exact thing. And here we just figure out what the dy compared to the what the value that we know of. Do you guys understand? By the way, this is actually my first YouTube video ever to try to approximate a value. It was very shady though. That was like 12 years ago.
Still on YouTube.
Probably is. It's like one of my first video, like how I got my first job. So I went into that video, I clicked like 1,000 times. I have like 1,000 views. Yeah, I literally like just open a new browser, just click on it, open a new browser, click on it. And I went to, because you know how you cannot get your first job if you don't have experience?
Yeah.
Right? And then you don't have your job, how do you get experience? And then so I went to apply to every single school in Orange County at least twice. I went to interview probably 20 schools. Even Oak Ridge doesn't want to hire me. Evans doesn't even want to hire me. Memorial Middle School, where graffiti everywhere in the school, doesn't want to hire me. Huh?
Why you go to middle school?
I didn't care. I just want to become a
He
teacher.
just wanted a job.
I just want a job. Like, why would you want to work in Walmart, right? But it was like you have no option. You have like no option. So what I did is I applied every single school. I got applied to thing, and I went to Cypress Creek twice. And second time they actually hired me for science teachers. I'm like, no, I'm not teaching earth-space science. And so the third time they says we want a math teacher. So Olympia rejected me twice actually. So at the time I was like very frustrated. So I was like, I'll get any job. So I applied everywhere. So eventually I make a video. I was like, you know what? I can teach. I'm gonna just have to show them. So I make a video and I says, look, there's 1,000 people watch my video. I have to know how to teach. Otherwise, those 1,000 people would not be watching my video. It turns out like 1,000 people is me. But I never told him that. Huh?
Mr. Ye fraud.
I skimmed the system, yes. But sometimes you have to fake it until you make it, right? Yeah, that's my son.
I know, but like.
Mr. Ye, your kids are so cute.
Which one?
Your first live stream is you taking your kid to the
Wait,
library.
we need which
One of them is better. The other ones I call him Peter, which is pain in the ass. But see, I'm not only mean to you, I'm mean to everybody. All right. Shh. Okay, so I'm going to show you a question that we're going to talk about error as well. Error.
Error too.
Because this is kind of look like here. Okay, so this is also another common question that usually on competitions rather than on the AP exam. But this is a question, it becomes obsolete. The estimate error, because right now, like computer can do a very good job about estimate error, but we're gonna look at this question in a second. They say the measure of radius of ball bearing is 0.7 inches. Show in figure, what figure? This is a 0.7. But there is some type of error. When you measure like this, there's some type of error. Like sometimes it could be temperature. Temperature could be affecting how the ball, if they're expanding, right? So if you have room temperature as a very cold temperature as outside like 120 degree, you put in the car, then the ball is gonna have a different dimension, right? So then you say, okay, the major radius of ball bearing is 0.7 inches as a show. The measurement is correct within 0.01 inches. Estimate what is a propagate errors. And there's an equation for propagate error before on the top. You see that measurement error and the propagate error. So they say, well, what will be the error? What do you guys think? There's the error and radius.
That's not what equation that we use.
You can, but we can use just differential. You can estimate how much the error is. Just think about what I just did.
Okay.
First of all, which equation I'll be using? No, I didn't talk about this last year. I didn't talk about this at all last year. Huh?
Why are you?
Because some competition question is gonna be involved with it. You saw this question before, right? But we used that to talk about in Calc BC, AB and BC. So I will not skip it. So I'm just trying to say, if the radius is off by 0.01, you know how something you have plus minus, there's uncertainty.
Yeah.
Uncertainty of you have plus minus 1, how much volume have it cost, right? So basically, you just take this function, you say, oh, okay, well, I have, what will be the volume here? What's the volume of this ball?
4 pi times 0.7.
4/3 pi r cube.
Yeah.
You guys forgot already?
Where?
I can take a differential here, dV, which is that small change in volume. And that's equal to 4 pi r squared dr. Right? Dr is small change in r. So we say we already need 4 pi, and we said this is 0.7 squared. And dr is what? 0.01. Is that okay? So that's how much the error is. The error is going to be, or end up working everything out. It should be 0.06158 inches to the third, and there's a plus minus because you might expand a little bit due to different temperature, it might shrink a little bit depend on different temperature, or your measurement error, your technique is wrong when you measure a bearing, a roll. Then you have some type, you didn't tie the screw tight enough. That could be involved with everything. So that's how much the volume that this is a propagate error. Yes.
How come you're using 0.01? Why isn't it 0.2?
I think the question says 0.01.
Yeah, because it's.
What are you saying is because it could be 0.01 this way and that way. So wouldn't it add up to 0.02?
But you have a plus minus. You have plus minus error. You have a propagate error.
So propagate means it goes both ways.
Yeah. So like for example, that if you look at, I don't know, this one, do they have plus minus? No. They don't. It used to have like plus minus on something like how much is sugar, plus minus 1 gram, right? You might have an error of that small error, that's uncertainty. And that's something that you have to know. So the error is very easy. You just figure out the equation, take a differential. This is gonna be how much it change it in term radius, how much it affect the values. the volume is gonna be plus minus of this. Now, sometimes a question on the older style AP exam question, they do ask you like, you know, if you know the relative error and the percentage error. Percentage error is basically is this divided by total divided by the total volume. So that's gonna, if you divide it by total volume, that's gonna be a percentage error, right? Because you got a total volume, let's say total volume is 10, then you take that the small error divided by the total volume, then that's gonna be that. Any
So
questions?
you divide that over 0.7?
No, you'll divide it by this by the plug in 0.7 into the volume equation.
Yeah. So you divide by 0.7.
No,
No.
you had to plug in the volume equation first. You had to figure out what the total volume first.
Oh, I see what you're saying. Never mind.
Yeah, so that would be a percentage error. Now they don't longer ask this type of question, but doesn't mean that it won't show up on competitions. So I want to go over that. And also there was another thing that I didn't choose to go over, but it's becoming very rare, is where they start with the Newton's method. I think that's my first video, or that's my second video, which was Newton's method. Newton's method used to be on AP exam, but it's no longer on AP exam. What?
Oh, I thought it was like an F.
No, there was a plus minus error.
Uh,
So your volume could be plus a little bit this. Even your radius only increased by 0.01, but your volume should increase by 0.06 or minus 0.06 because they are different dimension. And you should know that this from related rate,
yeah.
and that's how much it changes. Okay.
I thought it looked like F squared on like.
Okay. So what we're gonna do is we're gonna go to the next chapter. Tomorrow you have optimization tests. What happened? Give you space. Oh yeah, there was plenty of space. There was plenty. Of
Sure.
space. Margin of 0.02. Okay, how much time I have?
22 minutes. Hey, but you gotta eat the last one. I thought we knew it. No. Yeah,
All right, I'm just gonna go over a certain thing for those students that never take Calc 1. So what we're gonna do is integrations, and we're gonna do basic integration. So integration is actually very easy. So there was two type of integration. There was indefinite integral, and there's a definite integral. What's the difference? What? One has a bound, so this is a definite integral is between a to b of f of x dx, right? And this one just gonna be like f of x dx. And you guys already learned that last year. You know how to take integration, so I'm not gonna go through a whole lot. But integration of, let's just say integration of a constant, integration of constant dx, that's equal to what? What's the integration k? Kx plus c, thank you. Okay, so what's the integration of x to the n dx? X to the n plus 1 over n plus 1 plus c. You should know how to take integration of that. Is this okay?
Yes.
Right? So Kushif and Raphael and Jing, I need you to take integration of 3 square root x plus 5 over square root of x dx. They got it. They got it. Come on, man. Khrushchev?
Listen, when you're only hearing it and not looking, it sounds a lot worse.
And don't forget plus C. Unfortunately, I have to cover all the things on Calc 1 because I have to make sure those 3 students go across the board. But Rajesh, I won't laughing because those 3 students are doing better job than you do.
I know.
Yeah, that's pretty funny. The second year, you're still behind those people at first year.
It's like every other day. It's relief.
Raphael, you know how to do it? Sophia, you gonna help her? Him. Sorry.
She needs to help herself.
Vincent, be nice to Khrushchev. Stop calling him fat. I know. Khrushchev, you know how to take integration? So it turns out all the basic math still apply. I haven't taken integration yet. But this should give you 3x plus 5 times what? X to the 1/2 over what? 1/2 is 2, right? And then plus c, so it'll be 3x plus 10 root x plus c. So Chef, you got it?
Yeah, no,
Beef is crazy.
Why does Vincent keep on bullying you?
Vincent is retarded. I don't know.
Whoa.
Yeah,
No one's pulling
Jing, you got it? Understand? Okay. So we kind of talk about multiple things at the same time. So then you should know how to take a derivative of sine of x. That's equal to cosine of x. Now, what's integration of let's say cosine of x? What is it? Yeah. So because you know that if you know that you take a derivative of one of them, so that means antiderivative should give you this the same thing. So what's the derivative of cosine of x? Negative sine of x. But what's integration of sine of x? Negative cosine of x plus c. Hopefully you guys know this. Now, with the same logic, do you know what is integration of secant square of x dx? I need to ask Jing. Do you know what's integration of secant square of x dx is?
You made me write down the sexes of secant.
What's going on? What's the integration of secant square, Jing? 10 of x, good job. Is that okay? So because derivative of 10 of x is equal to secant square of x. Now, what is integration of secant of x, tan of x. Dx, sorry, it's gonna be not. Yeah, what's the integration of secant of x, tan of x? Secant of x plus c. Is that okay? So because derivative of d to the dx of secant of x equal to secant of x, tan of x. Okay, so what will be integration of cosecant square of x dx? Negative cotangent of what? X plus c, is that okay? And what's the integration of, so because derivative of a cotangent of x is equal to negative cosecant square of x. And what's integrate cosecant of x and the cotangent of x dx? What will be the integration of cosecant of x, cotangent of x? Negative what? X plus c, because d to the dx of CSC of x, that's equal to negative CSC of x, COT of x. And there we go, there's all the integration for the sign. Now, why is plus c is very important?
Because when you take a derivative of something, the constant goes away, so that if you take the integral, it can have any constant with it.
Right. So there's a difference between a general solution and particular solutions. So what is the difference between general solution and particular solution? Oh, by the way, do you guys know how to take the integration of this one? Everybody probably gonna have a hard time with this one.
Wait,
Sine of x over cosine square of x.
no,
Wrong.
it's cosine squared. Oh yeah, no, you're right. Never mind. Yeah, my bad. Wait. Yeah, you're right.
So be careful how this question's written, right? How many of you guys got it right? How many of you guys got it wrong? Nobody? Well, integration of a sine of x over cosine of x times 1 over cosine of x. So that's equal to 10 of x. That's equal to secant of x dx, which is sexy 10, which is here is going to be secant of x plus c. Is that okay?
Yes.
Okay. So let's talk about the difference between particular solution. So this is called a general solution. And a particular solution is you're going to have an initial conditions. So if I have f prime of x is equal to 1 over x squared when x is greater than 0, can you find f of x if there's an initial condition at f of 1 equal to 0? So can you find what f of x is? Now,
Yes.
this should be easy for you guys, but it's remember we have 3 students that's on straight from BC to AB or AB to BC. So what happened if you think about a graph, 1 over x squared graph, it's gonna look like something like this, like this. So it's gonna look like this. But there's only one thing that is only one equation that cross like 1, 0, like this point. There's only one equation that does that. So there's a lot of general solution because you have plus c. So it's basically a vertical shift of the whole functions. So that function could be anywhere, but there's only one that has 1 point here. So that we call it this particular solutions. So what we can do is we take an integration of 1 over x squared dx, and that's equal to f of x, right? So that's equal to integration of x to the negative 2 dx. What's the integration of x to the negative 2? So x to the negative 1 over negative 1 plus c. Why is that c is important? Because that c is important because right now you have to evaluate that c. So that's going to be negative 1 over x plus c. Now they also say there's an input, there's output, and there's an input. So that means at f of 1 is equal to 0. That's equal to negative 1 over 1 plus c. So c has to be 1. So that means the function has to be negative 1 over x plus 1. Okay, but basically is we find out which one of all the vertical shift, which one of all the red line is a particular, all the red lines general solution, but only one across the blue dot is called particular solution. That's a particular in that way. Got it? Okay. Let you practice a question. Now I might have a double C now, so I have f double prime of x equal to x to the negative 3 over 2. I have f prime of 4 is equal to 2. And if you have f of 0 is equal to 0. So then, look, in order to find out f of x, you must take integration. But every integration has a plus c. But they also have two initial conditions here. There's an initial condition for the differential equation. There's an initial condition for the original equation. But you have to base on that c. So that c has to be careful. Because you're going to get one c. You're going to find out what that c is using initial condition. And then you're going to take an integration based on that new c. And then you have to do an integration again and then find out another c. Hopefully that c come out online. So let's try this one. Make sure everybody knows how to do it. Those people knows how to do it. Help the people don't know how to do it. Basically is like this. And then we're done with 4.1. We're going to move on to the 4.2. And then you have test tomorrow. Oh, you have test tomorrow. Then we're going to do 4.2. You guys already learned this. The AB student not even complaining. You whining more than other people. That's how ridiculous this is. Like I don't hear Khrushchev complain. I don't hear Jing complain. I don't hear Raphael complain. I hear Ria complaining. I hear.
Okay.
That was uncalled for. That was straightforward. Sorry. Then don't complain. I don't have to call on you.
Honestly, I'll still do your work.
Yeah, you're welcome. Like, trust me, I'm not more harsh on you than my own kids. My own kid, they are shitty at ping pong. I throw a ping pong paddle at them. So I'm not treating you differently. I treat everybody the same shit.
Thank goodness.
Yeah. If you don't want to get called out and just don't appear, then I don't call out.
Yeah, that's how we make these kids with people battle. I got
Lyndon, my handwriting is equivalent to your handwriting, so, so you can't make fun of me.
Oh my goodness. Oh my god. I would rush to get more.
They haven't really been ringing the bell today for some reason.
Oh. Wait, but then where?
How old are you gonna be this year or next year? On my 25th.
Why is random people just like putting random chat in the chat?
Author of the what country are you?
It's so random.
Hey, you're getting views.
Yeah, you're getting views, Mr. Yeah.
I don't know who's.
Or they could be like on my alt account.